So we're going to solve today this composite number question, which is in the specimen paper, and it's kind of a different question. So let's read the question first. So the question says actually you have to define a class called composite, where you have to have an array, the m and n are the dimensions. This is the parameterized constructor which will initialize the dimensions. This is the function which is going to take a check whether it's a composite or not, and then this is the function is going to fill that with the composite number, and there is a display, and the question says that you have to define all the question along with the main. Okay, so let's go to Luce and see how it happens. All right, so here we are, and I already have coded this, and I'll just quickly explain this to you. So I have a class composite, and I have declared an array without any dimension right now, because that has to be taken from user, and then m and then other dimensions, rows and column. Now this is a parameterized constructor where dimension will be passed from the main function. These will come from the main, and then they will go and get stored to m and n. This has been told in the question as itself. This statement is not there in question, but that is understood that whatever m and n has been passed, you have to assign memory to the array. So that's what you did here. ARR equals to new in m and n. All right. Now here's the function composite. Now it's taking a parameter p. Now the p parameter is the question is something like that. You have to fill the array of m into n dimension with first m into n parameterized composite numbers, right? So this p has been passed to it. So this function is actually checking whether it's a composite or not. So which are composite number which has more than 2 factors? Okay. So now we have taken a variable counter which is just checking how many factors a number has. So the p which is passed to be checked as a composite, we are running a loop from 1 till p. We are dividing the p with every value of I, and if it divides, that means it's a factor, so we're increasing the value of counter. If the counter happens to be more than 2, that means it's other than the prime number, so it's a composite number. We return 1, else we return 0. Okay, I don't think there's any confusion over this in this set of lines. So let's go down and see the other function. So when I go down and see the other function, just give me a moment. All right, so the fill function, and then I'll pull up the rest of it. Yeah. So here we have fill function. Now the fill function is important. The logic is that we have to actually fill the first m into n dimension. Suppose the row is 2 and column is 3. So the total number of elements over there in that is going to be 6, right? So we have to fill a single dimension array with 6 composite numbers, and then from single dimension array, it's always easy for us to shift it to a double dimension. Whenever whenever you have to deal with double dimension elements, it's always better to shift it in a single dimension, do the process in single dimension, and then put it back. Just like sorting the elements of a double dimension. There also you have to shift all the elements from the double dimension to single dimension, then shift it back. That's what we are trying to do here. So we have declared a single dimension array with res dimension, which is m into n. All right. Now I 0, and we have initialized, and k equals to 1. Now we are running a loop from I till all the elements are filled. What we are doing, we are calling the function composite. Okay, we are calling the function composite and sending k to it. Now k is the variable which is starting from 1. So this is the value, this is the variable which will take all the values 1, 2, 3, 4, 5, 6, 7, 8, all the values. From these values we are going to check whether it's a composite, and if it's a composite, we'll shift it to the single dimension array. So if that composite function, when we send k to it, if that returns 1, that means it's a composite. So that value of k goes to the single dimension array. And similarly, the value of I increases, so the next element will be put into the next position. Now k increases. K has to increase, whether it's a composite or prime, k has to increase. So k will increase out of this if loop, because I is the array which is holding the composite only. So the value of I shall only increase when we get a composite number. But the value of k shall increase every time, whether it's a composite or a prime. Okay, that's why the k is outside the if loop. Now what we are doing, we are just shifting all these single dimension composite filled array to a double dimension array. So we are running a loop from uh, in m into n, and we are just shifting it all the elements from here to the double dimension. The value of single dimension is managed by this variable x initially, which is 0, and every time the number is shifted it increases by 1. Okay, then we have a display function. Let me just scroll up and let's see how the display function behaves. Just a moment. All right, so here comes the display and the main. Together I'll explain it to you. So here's the display, which is very simple, that you have to run a loop from m and n, and then you have to print it out, and you have to give, after the j loop ends, you have to give a new line, and then the I ends and the function ends. Now in the main program we have taken the dimensions. It's not mentioned in the question whether you have to take the dimension from user or initialize it yourself, so we initialize ourselves. So mm and nn are the rows and columns. We have created an object and passed this mn and n to the parameterized constructor. When we do this, I'll just quickly scroll up and show you where it is going to. So when we pass it, it goes over here and gets stored into this, through this mm and nn, it goes into m and n. Okay, and then the dimension of the double dimension array is fixed, or memory is allocated to it. All right, now we come back to the main again. So after passing the numbers to the parameterized constructor over here, what we do, we call the function fill and we call the function display. We are not calling the function isComposite, because isComposite, if you would have observed, I'll show it again, isComposite is actually being called in the fill itself. So you look over here, fill. In the fill itself, you're calling actually the isComposite, right? So isComposite, that's the reason isComposite is not called in the main. So this is the way this question is to be done, right? So thank you for giving your time, and I'll come up with the next video. So wait for the next video of the specimen paper. Thank you so much.